Hi, welcome to chapter 6, section 2. Oh my goodness. So, well, speaking of chapter 2, we're going to do a little bit of a throwback today. So in order to talk about our random variables, we want to be able to kind of do more to them. So my throwback is about when we were just looking at like full sets of data. This was actually in chapter 1, but whatever. Okay, full sets of data. And we would either like add all of the data points by a constant number, like adding everything by 5 or whatever, or subtracting, or multiplying everything or dividing everything by a constant. And so if you remember, we were looking at like when we did something like that, does it change the mean? Does it change the standard deviation? So real quickly, if we multiplied or divided all the values in a data set by a constant, then the mean and the standard deviation would also be multiplied or divided by that constant. Cool. So multiplying, dividing changes both the mean and the standard deviation, and you would just multiply the mean and the standard deviation by whatever constant you were doing with the rest of the data points. If you just added or subtracted all the values in a data set by a constant, then only the mean would change. You would either add or subtract by the constant that you were adding all your data points by to the mean, but then the standard deviation stays exactly the same, which kind of makes sense. If you just like shift your entire data set one direction, the spread of that data set isn't going to change, just the center. Okay, so keeping that in mind, now we're going to do this, but with random variables instead. Okay, so to demonstrate this transformation of our random variables, I'm just going to use an example we used in the last video. So this was just our random variable stood for rolling 2 dice and then finding the sum of all the dots on the 2 dice. Okay. So we know when we roll 2 dice, our outcomes could be from 2 through 12 with its probabilities like this. Okay, so I have that typed into my calculator already so that I can find the mean and the standard deviation with like the original data normally. So going into stat, go over to calc, one variable stats. Remember our x values are in L1, frequency list is L2. Hit enter. Okay, so we get a mean of 7, which means in the long run, if we like rolled 2 dice a bunch of times, the average number that we would roll, or the average sum that we would roll is 7, with a standard deviation of 2.415. So we're typically off from the mean by 2.415. Okay, so if we have that mean and standard deviation, let's try to transform our data values now. So let's pretend we are taking our dice and just drawing an extra 3 dots on every single side of the dice for both dice. So that means instead of a sum of 2 now, that would be now the smallest number on each die is, on each die is 4. So our smallest sum that we could get would now be 8. Okay, so then that means everything will end up getting added by 6 because we're adding 3 dots to each dice. Oh gosh, I'm really bad at grammar, guys. All right, 9, 10, 11. So that'll change all my random variables, or all the outcomes of my random variable, to numbers from 8 to 18. But the probabilities would still be the same because when we roll the 2 dice, like it's still going to be the same probability because we're doing the same action, just different numbers for the outcomes. Okay, so on my calculator then, I'm going to be lazy, and instead of retyping everything into L1, I'm just going to go into L3, and I know I'm taking all of my numbers from L1 and adding 6 to it. So I'm just going to set my own formula, L1 plus 6, and have my calculator add everything for me. So now it starts at 8, goes all the way to 18. So now when I calculate my mean and my standard deviation, I'm going to use StatCalc1, one variable stats. This time my X list, though, instead of L1, it's going to be L3 because that's where I did all the transformations. But my probabilities were still exactly the same. So still L2 for the frequency list. Calculate. Look at that. Okay, so my new mean is now 13. And my new standard deviation is 2.415, which I don't think it changed from the last time. All right, so as you can see, when we transformed our data values by adding 6 to everything, our mean also added by 6, but our standard deviation did not change. So it's very similar to our transformations that we did way back when we were just talking about regular data sets instead of random variables. So same sort of behavior. If you're adding or subtracting, it only changes the mean, does not change the standard deviation. So this time, let's try taking our original data set, or our random variable, and this time we're going to transform by multiplying. All right, so this time we're going to multiply all our outcomes by 2, which means now my random variable outcomes are going to be 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. Okay, but again, same probabilities because we're still rolling the 2 die. Whatever, every face of the die just got multiplied by 2. All right, so now in our calculator, let's do this real quick. I'll just go into L4. So I want to take all my numbers in L1 and multiply it by 2. So here's my new list of outcomes. And then calculating my mean and standard deviation then, instead of L3, it'll be L4 because that's where I have my new data points. Probability values are still the same. Calculate. Boom. All right. So we have a mean now of 14, which makes sense. If we multiply all our data values by 2, then our mean's also going to be multiplied by 2. So we started with a mean of 7, now it's 14, which is times 2. Our standard deviation, if you look, 4.83. Our original standard deviation was 2.415. So yeah, it sounds like that also got multiplied by 2. Okay, so in summary, if we transform a random variable by adding by a constant of a and multiplying by a constant of b, then in general, the mean of the transformed variable, we'll call it y, is going to change by both multiplying and adding. Because we said multiplying and adding will change the mean, but adding and subtracting doesn't change the standard deviation. So when we look at the standard deviation of the new transformed variable, we just take our old standard deviation and we multiply by whatever that constant is. But we make sure that we are multiplying by the absolute value of whatever that constant is. Because even if we multiplied by a negative number to all of our data values in our random variable, remember, standard deviation is a measure of spread, so it's that average distance from the mean, and distances are never negative. And so we just want to make sure whatever we multiply by, it's still going to be a positive number when we talk about the standard deviation. So that's why that absolute value sign is there. All right, the other thing I wanted to talk about in this section is actually combining random variables together. So if we have like 2 separate events going on, like if one of them was rolling 2 dice and then the other one was like, I don't know, flipping a coin or whatever. Or sorry, no, you can't flip a coin because that's not a random variable because it's got to be numeric. I don't know, something else numeric, some sort of game that we're playing, whatever. If we wanted to combine the 2 together to then find like a new mean or a new standard deviation, we can do that as long as the 2 events don't actually affect each other. So if the 2 games aren't like dependent on each other, so the 2 events have to be independent of each other. So if we're combining 2 random variables together, let's say the 2 random variables are x and y, then the means would just be the mean of each random variable added together. And that'll give you the mean of the combined random variable. For the standard deviation, the formula actually is for the variance. So if you remember, variance is the squared version of the standard deviation. So if you take the standard deviation and square it, you would get variance. So for the formula for the variance, you can just add the 2 variances together. So find the standard deviation of just one random variable x, square it, and then find the standard deviation of the other random variable, square it. Then you can add them together. You cannot just add the 2 standard deviations together, so that's important. But at the end, this will give you like the overall variance. So in order to find the standard deviation, then just square root it. Okay. Let's say we have 2 random variables that are being subtracted instead of being added. Then the means would just subtract, easy. but then the standard deviations still get added. So this is not a typo. If you are subtracting your two random variables, their variances still add. So remember that one because it's not intuitive. Okay, so for this one, again, same thing. Once you find the new variance, then you'll have to square root it to find the standard deviation of your combined variables. So let's do an example so that we can kind of see how this is used. So SpongeBob and Patrick are friendly competitors in boating school. Both are about to take the Bikini Bottom boating exam. They agree that if one of them scores 5 points or more better than the other, the loser will buy the winner a Krusty Krab pizza. Delicious. Suppose that in fact SpongeBob and Patrick have equal ability so that each score varies normally with mean 24 and standard deviation of 2. Their two scores are independent of each other. What is the probability that their scores differ by 5 or more points in either direction? Ooh, okay, so a lot of words here. First, I am a very visual person, so right when I saw like varies normally, that made me think normal curve. Okay, now that I have a normal curve, then I need to be able to label the mean and the standard deviation then. Well, here I have two different scores, right? I have SpongeBob's score and I have Patrick's score. The problem also said that they both have equal ability, so each of their means is 24 and standard deviations is 2. So I'm going to say the mean of SpongeBob is 24, the standard deviation of SpongeBob is 2, the mean of Patrick is 24, the standard deviation of Patrick is 2. Okay, and so we're trying to find them, like the difference in their scores. So it says, what is the probability that their scores differ by 5 or more points? So we are subtracting their two means together to see what the difference between their scores are. So that means when I find the mean here, I'm really doing the mean of SpongeBob minus Patrick. Could have subtracted the other way, it really doesn't matter. Okay, so we'll call it SpongeBob minus Patrick. So that means using our rules about combining our random variables together, we are doing the subtracting one. So I can just take the means of each and subtract them. 24 minus 24 would be a mean of 0. Okay, and then for their standard deviation then, of SpongeBob minus Patrick, we would have to find the variance first. So the variance would be the two variances added together. So remember, that's the weird one where the variances still add. So the variance of SpongeBob is 4. The variance of Patrick is also 4. So that means the overall variance is 8. But we want the standard deviation, so I'm going to square root 8, which is 2 point something. We'll round it to 2.828. Okay, so then for the shading of my normal curve, we're looking for the probability that their point values differ by 5 or more points in either direction. Okay. So we're basically saying SpongeBob minus Patrick should be 5 or more, or SpongeBob minus Patrick should be -5 or more, because in either direction. Meaning SpongeBob scored 5 points more than Patrick, or Patrick scored 5 points more than SpongeBob, because either way, someone's got to buy that pizza. Okay, so this is the probability that we're looking for then. All right, so at this point, we do our problem like normal. We find our z-scores for each. So we have -5 minus a mean of 0 divided by the standard deviation of 2.828. We'll also have a z-score of 5 minus 0 divided by a standard deviation of 2.828, which is really the same z-score, just one positive, one negative. So I got z-scores of plus or minus 1.768. So again, I'm going to do this probability in the calculator just to save me a little time so I don't have to use the table. So just to recap, this is second VARS, normal CDF, so number 2. And remember, it'll ask you for lower, upper, whatever. Since my two areas have the same z-score, it really means that these two shaded areas are going to be the exact same probability. Just multiply it by 2 at the end to find the two shaded areas. So I'm just going to find the left side here. So the lower, it automatically started with -1 times 10 to the 99th power. So this is just basically like -100,000 or whatever. Cool. Which is, that's where we're starting to shade. We're ending our shading at a z-score of -1.768, or if you want to do it with the -5 in there, cool. The mean, since I'm using z-scores, will be 0. The standard deviation will be 1. Remember, it's always 0 and 1 for z-scores. If you're doing a -5 for your upper, then your mean would be 0. Your standard deviation would be 2.828. Paste. Enter. Cool. So this is the probability of the shaded area on the left side. Since we want both, we just got to multiply that by 2. Times 2 equals. So 0.077. What is the probability that their scores differ by 5 or more points in either direction? We can say the probability that the difference in Patrick and SpongeBob's scores are 5 or more in either direction is going to be 7.71%. That's it. Thanks for watching. Bye.